Sunlight has no color at all. It's white. The space around this planet is pure black. Nothing up there is blue. And yet, right now, if you looked up, that's exactly what you'd see. Somewhere between the sun and your eyes, something is happening that shouldn't be possible. You've seen it every single day of your life. You've never once questioned it. The sky is blue in the morning, it turns orange and red by evening, and somehow you've never stopped to ask why sunlight, a pure white light, keeps changing its story depending on the time of day. Once you understand what's actually happening above your head, you'll never look at a sunset the same way again. Let's start with something you probably think you already know. Sunlight looks white, but white isn't a real color. It's every color, all mixed together. Red, orange, yellow, green, blue, and violet, all traveling side by side in a single beam of light. Back in the 1600s, a scientist named Isaac Newton grabbed a plain glass prism and pointed a beam of sunlight straight through it. Everyone before him assumed the prism was somehow creating color out of nothing. Newton proved the opposite. The white light already contained every color hidden inside it. The prism didn't add anything, it just separated what was already there. Each of these colors moves as a wave, and each wave has a different length. Red light stretches out, long and lazy. Violet light packs tight, fast little ripples. When all of these waves hit your eye at the exact same time, your brain doesn't see 6 colors, it sees white. Sunlight was never one thing, it was always 6 things wearing a disguise. Now send that beam of light on a journey. It leaves the sun, it crosses 93 million miles of empty space, and then it slams into something it never touched before, Earth's atmosphere. The atmosphere is packed with tiny gas molecules, mostly nitrogen and oxygen, far smaller than the light waves passing through them. And here's the part most people never learn in school. Light doesn't just pass through those molecules, it bounces off them. Scientists call it scattering, but not every color scatters the same way. Picture throwing a bowling ball through a room full of tiny obstacles. It barely notices them, it just rolls straight through. Now throw a handful of small marbles through that same room. They bounce off every single obstacle, ricocheting in every direction. Red light behaves like the bowling ball. Blue and violet light behave like the marbles. Those long, lazy red waves mostly slide right past the molecules without much interference. But the short, tight waves slam into every molecule they pass, scattering in every direction, again and again, across the entire sky. A physicist named John Tyndall figured this out in the 1800s, and a scientist named Lord Rayleigh worked out the exact math behind it. The shorter the wavelength, the more violently it scatters. Blue light scatters nearly 10 times more than red light. So technically, violet should win. It scatters even more than blue. But your eyes are far less sensitive to violet, and a lot of it gets absorbed high in the atmosphere before it ever reaches you. Blue is the strongest signal your eyes can actually pick up. That's the whole secret. The sky isn't blue because blue is being added to it. It's blue because every other color got out of the way first. There's one more twist hiding in plain sight. Look straight up on a clear day, and the sky is a deep, rich blue. But drop your gaze toward the horizon, and that same sky fades into a pale, washed-out white. That happens because you're looking through a much thicker slice of atmosphere near the horizon, packed with larger particles like dust, water vapor, and pollution. Those bigger particles scatter every color almost equally, a process called me-scattering, which drowns the blue in a milky haze. The dirtier or more humid the air, the paler that horizon glow becomes. But if all of this is true, here's a question that should be bothering you right now. If blue light scatters in every direction, shouldn't the sky look the same no matter where you look, morning, noon, or night? It doesn't. And the reason why is about to change everything you just learned. During the middle of the day, sunlight takes the shortest possible path through the atmosphere, straight down to you. There isn't much air to cut through, so blue light scatters just enough to paint the whole sky, and the sun itself still looks white or pale yellow. But at sunrise and sunset, everything changes. The sun sits low on the horizon, and its light has to cut through the atmosphere at a steep angle. That path isn't short anymore. It can be up to 40 times longer than it is at noon. Along that much longer stretch, the blue and violet light scatters away so many times that almost none of it survives to reach your eyes directly. What's left, the long, lazy red and orange waves, finally pushes through and lands right in your eyes. This is also why sunsets after a rainstorm or over a smoggy city often look far more dramatic. Extra dust and moisture in the air scatters even more of the remaining light, painting the sky in deeper oranges, pinks, and purples. You're not looking at a different sun, you're looking at what's left of the same white light after the sky has already stolen every color it could reach. Photographers have a name for the 15 or 20 minutes right after the sun dips below the horizon. They call it the blue hour. Once the sun itself is gone, the last of its light still grazes the upper atmosphere from below, and at that shallow angle, blue wavelengths scatter back down more efficiently than any other color, briefly painting the entire sky, buildings, and even snow in a deep, cool blue glow. It only lasts a few minutes, and then it's gone. And since we're already tearing apart everything you thought you knew, here's one more myth to bury. Most people assume the ocean is blue for the exact same reason as the sky, simply reflecting the color above it. That's only part of the story. Water molecules themselves actually absorb red light far more easily than blue light. As sunlight sinks deeper into the ocean, the red wavelengths get soaked up first, leaving mostly blue light to bounce back to your eyes. The sky lends the ocean a little of its color, but the ocean was already blue on its own, one absorbed wavelength at a time. There's a detail hiding inside every single sunset that almost nobody ever catches. For a second, sometimes less, right as the sun disappears below the horizon, a tiny flash of green light can appear right at its edge. It's called the green flash, and it happens because the atmosphere bends different colors of light by different amounts, acting like a weak prism stacked right above the horizon. The French novelist Jules Verne was so fascinated by it that he wrote an 1882 novel called The Green Ray, built around a legend that anyone who witnesses the flash finally understands their own feelings and the feelings of everyone around them. For decades, some scientists doubted it was even real. It wasn't reliably photographed until 1960. Most people go their whole life without ever seeing it, standing under the exact same sky where it happens almost every single day. This same scattering effect can turn violent on a planetary scale. In 1883, the volcano Krakatoa exploded with a force thousands of times stronger than a nuclear bomb. Ash from that single eruption circled the entire planet within just 2 weeks. Sunsets stayed blood red as far away as London and New York for nearly 3 years afterward. People in London reported the sky glowing so intensely that fire crews were called out, convinced a building was burning nearby. Some historians even believe the eerie orange sky in Edvard Munch's painting The Scream was inspired by those exact sunsets. It wasn't a one-time event either. When Mount Pinatubo erupted in 1991, it threw so much sulfur into the stratosphere that sunsets turned vivid shades of orange and purple across the entire globe for months, and global temperatures dipped for almost 2 years afterward. There's one more sky color that terrifies meteorologists more than any sunset ever could. Right before a severe thunderstorm, especially ones capable of producing tornadoes, the sky can turn a sickly shade of green. Scientists still don't fully agree on why. One leading theory suggests that late afternoon sunlight, already shifted toward red and orange, passes through a storm cloud packed with huge water droplets and hail, and those droplets scatter the remaining blue light in just the right way to blend into a deep green glow. Storm chasers treat that color as a warning sign. When the sky turns green, they know exactly what might be coming next. And if you still think this is just how skies work everywhere, Mars is about to break your brain completely. Mars has almost no atmosphere left, and what little air it has is thick with fine red dust. That dust scatters light in the opposite way Earth's atmosphere does. During the Martian day, the sky glows a dusty butterscotch orange. When NASA's Viking lander sent back its first photos from the surface of Mars in 1976, scientists initially released an image showing a blue sky, almost identical to Earth's. It turned out the color calibration on the camera was wrong. Once corrected, the real Martian sky showed its true dusty orange color. Nobody had ever seen an alien sky before, and for a few days the entire world was looking at the wrong one. But right at true Martian sunset, that same red dust scatters blue light forward toward the sun, and for a few minutes Mars gets a sky that human eyes would recognize instantly. A cold, pale blue sunset on a planet where the daytime sky is the color of rust. And this same rule explains something else entirely. Astronauts standing on the moon look up and see a completely black sky even in the middle of lunar daytime, with the sun blazing directly overhead. The moon has no atmosphere at all. No gas molecules means nothing for sunlight to scatter off. There's no sky to scatter into, so there's no color at all. Just the sun, the stars, and pure black nothingness, exactly like the view from space itself. So the next time you step outside and glance up, remember what's actually happening above you. Sunlight was never one color. It was always six, and every single day, your own atmosphere decides which ones survive the trip to your eyes. The sky was never simply blue. It was a fight between light and air, happening silently over your head every second of every day of your life. What's the strangest sky you've ever seen? Tell me in the comments. And subscribe. Every week, something you thought you completely understood turns out to be stranger than you ever imagined.